David, that's not how you flip a pancake! Hey guys, we're back with our 48th episode of Cooking with Calculus.
Last week, we tackled the fundamental theorem of calculus using sushi.
This week, we're tackling rhyme and sums with pancakes.
We call this one the flapjack.
Oh, no way!
It takes a lot to make a stew.
A pinch of salt and laughter too.
A scoop of kids to add the spice.
A dash of love to make it nice. And you've got
Too many cooks.
too many cooks.
Too many cooks. Too many cooks.
Too many cooks.
Too many cooks.
Takes a lot to make a stew.
When it comes to me and you.
And him and her and the baby too. Too many cooks, it's true.
Hello, and welcome to Cooking with Calculus.
Thanks, Chef Stein. Why don't we get started?
Today we're going to be learning about rhyme and sums.
Ryan's sons, what are those?
Oh, David, they aren't Ryan's sons, they're rhyme and sums.
But what are rhyme and sums?
Great question, Tommy.
Rhyme and sums are an approximation method for estimating area underneath the curve. As you can see here, it may be very difficult to estimate the area under this curve using simple geometric shapes. Or is it? Using a rhyme and sum, we can use rectangles along with points on the graph to estimate the area underneath this curve. But before I go too far, let's start cooking.
So to make the best pancakes, we're gonna make the batter completely from scratch. So what you're gonna need is some all-purpose flour, some sugar, baking soda, some salt, milk, butter, and of course, eggs.
Whoopie dee scoop. Scoop dee dee whoop. Whoop dee scoop dee poop. Poop dee scoop dee whoop.
Man, I'm sure glad we made these from scratch. I feel so much more accomplished, and of course it'll be healthier for me.
Poop. Scoop dee dee whoop. Whoop dee dee scoop. Whoop dee dee scoop poop. Whoopie dee scoop. Scoop dee dee whoop. Whoop dee scoop dee poop. Poop dee scoop dee whoop. Whoopie dee scoop whoop poop. Poop dee dee whoop scoop. Poop. Poop. Scoop dee dee whoop. Whoop dee dee scoop. Whoop dee dee scoop poop. Whoopie dee scoop. Scoop dee dee whoop. Whoop.
So if we're using a right-handed rhyme and sum, we'll be using points on the right-hand side. So each subinterval, which we're doing 4 to 2, we'll be using the points on the right-hand side. So we'll be using 0.5, 1, 1.5, and 2. So when we put the rectangles on the graph, using the points that I had already specified, you can see that each rectangle is going to be above the graph. So this will obviously be an overestimation of the graph. And so if we add up all these areas using the points and multiplying by height times width, width will be our interval, which is 0.5, height would be whatever point we chose. We can add up all the areas and then we get whatever that number says. We'll add it in post. Oh, pop up. Am I out of frame?
Yep, go.
So, now if we're doing a left-handed approximation, we'll be using the points on the left-hand side. So we'll be starting at 1, and with the rectangles in here, you can see now it's going to be an under approximation. So again, if we multiply by base times height, using height as the left-hand side now, we'll get this answer, which obviously is a lot below our right-handed answer. Frame?
Oh, I haven't started yet. Alright, now I started.
Am I out of frame?
Yeah.
So now, we're going to be using a trapezoidal rhyme and sum. So, we'll have our left-hand point at 0, f of 0, and a right-hand point at f of 0.5. And let's call this B1 and B2 of a trapezoid. And a trapezoid area is b1 plus b2 over 2 times height. So we're going to add these two up, multiply by the height, but also divide by 2. And so if we do this over the course of all these, each of these points are going to be overlapping. So you're going to have 2 of this b1 and 2 of b2, 2 of b3. And the last point you won't, and the first point you won't. So basically a general rule is multiply by 2 on everything on the inside when you're setting up the equation. And then when you get the answer, you can tell it's a much better approximation. Still not perfect. It's an over approximation because this graph is increasing and concave up.
There you go, guys. That's our video about Ryan's sons. Next week, we're talking about Taylor polynomials using gummy bears.
Hey, and if you enjoyed, make sure you subscribe and hit the notification bell.